In the next set of problems on the sample file, we're first asked to determine whether two sets of points are parallel, perpendicular, or neither. In order to do this, we're going to need to find the slopes. If the slopes are the same, we're going to say they're parallel. If the slopes are negative reciprocals, in other words, if I flip them and the fractions are the same, one positive, one negative, then the lines are perpendicular. Anything else and they're neither. So we start by applying the slope formula, labeling these x1, y1, x2, y2, x1, y1, x2, y2. For our first slope, m, we get 6 minus 4 over 4 minus 3, which becomes 2 over 1. For our second slope, we get 5 minus 6 over 0 minus a negative 2. That becomes negative 1 over positive 2. When I look at these two slopes, 2 over 1, if I were to flip it, would become 1 over 2. This one's positive, this one's negative, so these are negative reciprocals. That's why my answer would be perpendicular. For this second problem here, or the fifth problem on the test, it says for the pair of equations, determine whether the graphs are parallel, perpendicular, or neither. So this is the same idea. The difference is instead of just worrying about slopes from points, we're going to take two lines that aren't currently in y equals form, put them into y equals form, and then look at what's in front of the x. So this line can stay just as it is. It has one y on the left, x is the numbers without an x. It's an exact correct y equals mx plus b form. This line we have a little work to do. First thing we're going to do is move the 9x. Plus 9x here, plus 9x here. That way it becomes 3y equals 9x plus 12. If I divide everything through by 3, that leaves me with y equals 3x plus 4. I'm now going to compare this line, y equals 3x plus 4, to this line, y equals 3x plus 2, by looking specifically what's in front of the x, because this is where the slope goes. In this case, I have a positive 3 in the first line, I have a positive 3 in the second line. Because these two lines have the same slope, these two lines are parallel. Number 6 asks me to find the slope and y-intercept of the equation. It's not in y equals mx plus b form, so that's my first goal. Currently, the thing that's out of place is this 3x. I only want y's on the left-hand side, so to move it, I'm going to subtract 3x. What I do to the left, I also have to do to the right. Remember that 24 and 3x are not like terms, so they cannot be combined. All I can do is leave the 4y on the left-hand side as all that's left, and then rewrite the right-hand side x's, then no x's. So the x's are negative 3x, the no x's are plus 24. Now that I have just y's, and I have things organized in the form x's, then no x, I can divide through by what's in front of the y. Here it's a 4, so this divides by 4, this divides by 4. 4 divided by 4 goes away and just leaves me with y. This negative 3/4, normally I tell you to put into your calculator and get negative 0.75 as a decimal, but really since we're trying to find the slope, it's better to leave the slope as a fraction. That way if you had to graph the line, you could do it as rise over run. So I'm going to leave this as negative 3/4 x. As opposed to the y-intercept here, which basically is a whole number if I divide. 24 divided by 4 should just leave me with plus 6. It's better for me to do that division. I can now pull out the slope and the y-intercept. The slope, or m, equals negative 3/4. The y-intercept, or b, equals 6. The other way they might want you to write this is as an xy coordinate. So the y-intercept could also be written as x value 0, y value 6.